In this video, we will look at AI applications. Previously, we looked at AI tasks, the general skills such as language or recognition that we might teach algorithms to do. Those general skills are deployed for specific applications, specific AI products that are put out there into the world. Now, this lecture really is quite a broad one. We really just want to get a sense of how AI applications have evolved over the decades, and where we commonly use them today, and perhaps ending on what AI really can't at the moment do. Now, one of the interesting things about AI, we're going to start with the history, is how far back that history goes. And when I ask people in classes, how old is AI? Many people say sort of, it started maybe in the 90s or the 80s. It is in fact the grandfather of all the major 4IR technologies. AI began in earnest in the mid-50s. And it was, I think in 1954 odd, that a programmer at IBM created an AI to play checkers. And after that, this group of scientists got together and proposed that they could pretty much in 2 months odd, with about 10 men, study or crack machine intelligence on a high level. So as we see here, an attempt we made to find out how to make machines use language, form abstractions, concepts, solve kinds of problems now reserved for humans, and improve themselves. And we think we can do it basically in a summer. And of course, the story is a lot longer than that. There is a long history of AI development. And there's both a long history of AI development and of what we call the AI winters, which is what we would equate to the first chapter's talk about periods of disillusionment, despair, denial. Here we see initial golden years of investment and research, and then funding dried up and research dried up. Then there was a boom in the 80s as companies became interested in expert systems that could advise in specific areas. And then another sort of winter. And then really, all of these things, as always, are debatable. These boundaries are fuzzy. But we could almost say that the coming of age of AI perhaps started somewhere around the middle of the 90s. And that we saw several things happening. So sort of around this area between about 94 to 2006, we saw some initial shoots, things like IBM beating Garry Kasparov in chess with Deep Blue, and we saw some autonomous vehicle stuff. But really around the middle of the noughties, if you like, the 2000s, we saw some very profound things begin to happen. And there's really two things that began what you could call the modern era of AI, which is, we're saying here, 2007 onwards. The first is the rise of big data. And we've seen with big data that a lot of the big data that we draw on is unstructured data. So photographs and text and that sort of thing. And the real boom in big data began with social media. So we could say somewhere around probably, the middle of the 2000s. It started earlier, but we really see a boom here, especially with the Apple iPhone, or smartphones in general, fueling the enormous wave of data provided by users themselves. Now, big data, as we've already seen with machine learning, which feeds, if you like, it learns from data. Big data really is the foundation of modern day AI. And then on top of that is the computing power that was always required through all these waves. What was missing was the required computing power. And interestingly enough, that came through gaming. Gaming, of course, became incredibly popular from the 80s. And as gaming became more and more popular, more and more widespread, specific computing power, specifically graphics processing units, so GPUs, was developed for gaming. And it turns out that this is not only the level of power, but also the type of processor that is needed to do a lot of AI problems. And we say here multi-core computing as well. So we have seen an absolutely dramatic increase. Now, that sort of last decade till now, or just slightly more than a decade, has seen amazing applications. And this is just really a sampling. So, of course, we saw the Google self-driving car starting really in 2009, using computer vision and machine learning to sort of teach itself to drive. IBM's Watson, which we saw previously under the demonstrations for natural language processing. It does have, on average, very good language capabilities. And one of the things it did there was beat humans on a very word-based TV show, the best performing humans of all time. Apple Siri, of course, acting as a human assistant, 2012, doing things like making recommendations, and also some planning systems in there, some things like diary planning, that sort of thing. 2014, we see facial recognition really getting a boost with Facebook's DeepFace. 97% accurate facial recognition, better than human experts. We saw 2016 Google DeepMind's AlphaGo, which beat humans, or the top humans at Go, which was always considered by scientists to be the pinnacle of games that computers would struggle to play against top humans. And this particular algorithm really can master many different types of games, complex games, and beat humans. Alibaba produced a language processing algorithm 2017 that outscored top humans at a Stanford University reading and comprehension test. 2018, Google's Duplex came out, so now we're back to digital assistants. Here we got a video. I suspect by now almost all of you would have seen this video, but for those few of you who haven't, this algorithm is again acts like a digital assistant. It can do reminders and book things into diaries and search for you, but it can also even the top level one make phone calls on behalf of users. So let's see it making a phone call in a difficult language environment.
See, how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when? Today?
Next Wednesday at 6 p.m.
Oh, actually we reserve for after 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh, no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Yep. Bye-bye.
So, I mean, for many computer scientists that I know, this was an absolute pinnacle in AI development. 2 more things maybe to talk about since then. So 2019, we before and after that as well, but many generative models in pop culture started to really surface. So we've already seen this person does not exist, fake faces or fake-ish faces, I guess you could say, but things like fake news stories, art, music, that sort of thing. Now, at the time, we had a language algorithm called GPT-2, which was actually so powerful in its ability to, for example, construct stories from a limited start that the company OpenAI hesitated, in fact, to release that algorithm at all. That thing has become GPT-3, which is even far more powerful and really has quite remarkable capabilities. So it's well worth looking up there. And then 2020, we can point to Alphabet's AlphaFold, which it could be one of the greatest advances in medicine of our time. So this is an algorithm that could predict the way proteins fold. This has been a 50-year grand challenge for both computer science and it really has its applications in drug development and disease prevention, because the knowledge about the way a protein folds is one of the great keys to treating diseases. So this is the kind of historical development, both through the initial decades, the last very exciting decade that I think has has unleashed the power of AI. And of course, where do we wind up today? Well, chatbots, of course, have become very common, deploying natural language processing, especially digital assistants, like we've already seen, are again really becoming more and more common on especially smartphones. Recommendation algorithms have been around for a long time. A good example there, which is used in the book, is Netflix's algorithm, which really helps them to get a user not only to go on and sort of browse around, but it increases the chance quite substantially that they will accurately predict what they should show the browser before he or she decides to quit Netflix and go do something else, play a game or something. Facial recognition has become a very big industry, especially in things like law enforcement, and there's a lot of money that has been spent by law enforcement on this, on facial recognition. But of course, it has many other uses. So we've already seen its power in Google Vision in the previous videos, and it really does have remarkable capabilities and commercializable potential. Knowing who a customer is as they're walking through the door. We know the security industry. So many different things we can do with this particular piece of technology. Software robots, as we've discussed, are not AI, but what we did discuss in the RPA section of Chapter 2 was the fact that we do expect to see a lot more AI being paired with RPA. And there, especially, we were talking about process analysis and improvement, which I think is a really big area for that. Non-humanoid robotics, so there we're talking to things like industrial robots, which traditionally just ran on basic programming. But now we're starting to find robots like this that need a lot more AI. And again, autonomous vehicles can almost be classed as non-humanoid robotics. So as we get more complex with robots, we do require more and more AI to help them to move correctly, to understand their environments, etc. Of course, humanoid robots are a nascent but upcoming thing. There, it won't just be movement, because with non-humanoid robotics and smart cars and things, a lot of that is just to do with the way that they move. But with humanoid robots, of course, it's the way that they move. So it's things like service robots that can, open a door for you, which used to be a massive challenge for robots, and has now been solved to move or walk or run over difficult terrain, or even mildly difficult terrain like stairs. Was always a massive problem. A lot of these have now been solved by AI. By machine learning, by getting those robots and reinforcement learning, getting them just to practice and keep on going and learning from their experiences. But, of course, humanoid robots will probably also include things like affective computing. So we've seen the ability, the expanding ability of algorithms to at least recognize emotions, which in a service robot, for example, would be quite important. But over and above that, perhaps in the future, to express emotion. And then finally, we've already seen generative models. As we've said, they can be used for interesting augmentation purposes, like, for example, helping musicians to write even more interesting music. But yes, they can be used for nefarious purposes as well. A rough rule of thumb from Andrew Ng, who we saw in a previous video, is that current AI can fairly easily do anything that we can do in about a second or less. So if you think about it, you can recognize a face in a second, you can pick up a word in a second, or a phrase, that sort of thing. Of course, this is now the interesting other side of the coin, is that there is so much AI can do, and every day there's a news story about AI that can do something that it couldn't do before. However, there's a bigger universe right now of things AI just simply cannot do. Tying a shoelace. These are some really random examples, but as our colleague Professor Terence van Zyl likes to say, tying a shoelace is perhaps one of the, it's currently way out of the range of AI. Why? Because even though it's a relatively uniform set of actions, shoes themselves come with different types of laces in different sort of configurations. The laces themselves have different materials and floppiness and relative smoothness. And it actually is something that is incredibly complex and interesting. And an AI wouldn't be able to do it. So think about that, you could teach maybe a 4 or 5-year-old to tie a shoelace. We can't currently get there. Gardening. Gardening is a very wide array of skills, of motion, of planning, of understanding, and even of intuition. And currently that is not something we think an AI could do. And of course, yes, the broader combinations of skills that involve the more human, intuitive, emotive, inspirational, plus cognitive skills. So things like psychology and leadership are not things that we currently would believe that an AI can do. So AI applications have come a long way, but they also have a long way to go.